Recording in progress. So this is the very last class of 1351 for spring of 2025. It's okay if you weep. All right. So the purpose of today's class is review session to get you ready for the final exam, which is going to be at 7:30 a.m. So who has a question for me? Can I go over the quiz? Okay, I can go over that again. Now I have already dropped the lowest 3 quizzes in the grade book, so you should be looking at your final grade there. I have dropped the 2 lowest lab scores as well, so you might have gotten a boost from that. But your final project, which is due today, is a separate category from the labs. So your lab score and your quiz scores should be final at this point. Are you saying something?
No.
Okay. All right. So what we're going to do here, right? What we had, the question here was fill in the missing code, and what we want is a generic binary tree. So you can see that the generic type T for C there. So what snippet 0 is going to need to do, because we want to use the compare function, right? Snippet 0. Oh, I'm sorry, this is the node class. Snippet, so the node class doesn't use the compare function. So it just needs an angle bracket T. We also need an angle bracket T on the declarations of the left and right subtrees, subnodes rather. And then on the constructor itself, we don't need the angle brackets. So the answer here is nothing. I should say, not only do we not need them, but we can't put it. Then the binary tree itself, this class needs the T extends comparable T. Now, I mean, probably if you were doing this in real life, if you were trying to be ultra generic, you would use the other formula, T extends question mark super T. But I decided not to put that level of complexity on this question. All right. On the allocation of the new node, you need an angle bracket T. Actually, empty angle brackets would be fine. Okay. So that's everything. Most of these were empty, were just angle bracket T. Any questions? All right. No questions. Advice for the student who wrote this myArray thing. Line 0 should have myArray T. Yes, it should. And in line 1, data should be final. No. I mean, I guess, yeah, no, it can't be, because we want to revise it when we grow, right? Line 1, the data should be static. I mean, no, because that would mean you could only ever have one array in all the universe. Line 2 should use less than instead of greater than or equal to. No, it shouldn't. Greater than or equal to is when you want to reallocate. Line 6 should have a myArray T. Where is line 6? So that's a constructor, so no. Line 0 should have myArray T extends comparable T. No, because we're not using the compare function anywhere. Line 1, 3, and 6, you should use object instead of T. Yes, it absolutely should, because we can't allocate a generic T. What we're doing on line 3 is illegal at the moment. Line 3 should use 2 times data instead of 10 plus logical size. Yes, that is correct. It should do that because you want to grow by factors, not by constant amounts. If you grow by factors, you'll have order n append time as the array increases. It's kind of hard to see that if you don't time it and whatnot. But if you just add, you're going to have order n squared time. So you definitely want to do that. Line 4 should use logical size instead of new data.length. Line 4 is yes, absolutely, because the problem is that new data is bigger than data, and you're going to get an array index out of bounds if you don't change that. Line 5 should use logical size plus plus instead of plus plus logical size. Yes, that is correct. You want the postfix operator, not the prefix operator, because of the value you get back. If you use the way it's currently written, you start inserting at position 1 instead of position 0. Okay, that's the quiz. Any questions? All right. Questions about something else? Yes.
So just to be sure, you can't use angle brackets on constructors.
That's correct. You can't use angle brackets on constructors. Just that's not a thing. Next question. You had a binary tree question, right?
Yeah, but I figured it out.
Oh, you figured it out. Okay. Okay, so I know that all y'all have questions. Give them to me. Yes.
I forget exactly what it's called, but when you're going through like the line of code, you have to pick out what each bit method declaration or something.
Mm-hmm.
The
Anatomy, sure. Yeah. Okay. Let's see. Anatomy. What lecture was that? It was something early. I think it might be basics. There we go. Anatomy of a function call. So in general, right, there is this rule that classes are supposed to start with capital letters, right? And everything else starts with a lowercase letter. So when you see system.out.println, you're going to assume that system is a class, right? .out, okay, with no parentheses, that means that I have a field and not a method, right? If there were parentheses, it would be a method. So this is a static field on the class system. Now, println is being applied to a field, an instance field in this case, because this instance is a static. There's an instance of the class print stream, I guess it is, sitting on the system class, and we're going to call an instance method of the static field out. Okay, so this is an instance method. This is a static field. This is a class. And we know that this last thing is a method because it has parentheses. Now, if you look at, say, java.lang.math, where math has a capital letter, it all starts with lowercase letters. So those first things must be packages. And do I have another one? Yes. Okay, so yeah, there's java.lang.math.sign3. So in this case, we know that math is a class. We know that Java and Lang are package elements. Sign is a function because it's being called directly on the class name like this. It is a static function. And so that's that. Does that help refresh your memory? Next question. Yes, Olivia. Yes, okay, the difference between comparable and comparator. If I am comparable, right, then you can compare me to other people like me, other professors, for example. I am comparable to other professors in that I am better, I answer questions, I'm better looking, and so on. I'm comparable, right? You can do a compare to of me with any of the professors in your other classes. But you, on the other hand, when you're looking at us professors, you are comparing us. You are a comparator. You are not a professor, but you are comparing professors. Therefore, you are a comparator. We are comparable because that comparable refers to us within our group comparing to one another. But a comparator is somebody outside comparing us. Make sense? And the same thing applies to the code. A comparator is a class used to compare two things, whereas a comparable has a single argument that compares to something else of the same type. I'm sorry? Okay, so what I could do, for example, is if I want to sort an array of strings, right? Strings are comparable, right? So if I call, let's just write a little code snippet. So public class CVC. So I'm going to say static void main args. Comparable string C1 equal hello. Dow. Comparable. Oh, cannot be converted to a string. That's good. Okay, so I'm going to change the type here. Okay, so C1 and C2 are comparable to strings, and therefore I can call C1.compare to C2 in order to find its relative ordering, right? But type C is not a string, right? C is just an anonymous inner class that implements the interface comparator. And I can use C to compare C1 and C2 and get the same answer. The way I wrote it, it's going to get the same answer, which is kind of boring. But the point is, C1 can compare itself to another string, so it is comparable. C is a different type than string, but it knows how to.
How the fuck you get terminated, nigga? What shift you miss?
Hello.
Oh, last week?
Hello.
Last week when you left to study for?
Do you have a question or do you need to mute your mic?
That shit ass.
All right. Next question.
You got one that pill.
Whoever you are, please mute your mic. I know I can mute people.
You gotta get that pill. No wait.
All right. I muted somebody. Hopefully it's the right person. All right, next question. Yes.
Can you like review how the comparison function of greater than and less than?
Oh, okay, sure. I think is that even in here? Okay, I think I know what to do. I think it's this program, yeah. Okay, this is the one I wanted. So the idea is, if I want to compare things, A dot compare to B less than 0 is the same as A less than B. It's also the same as A minus B less than 0, right? Or A minus B greater than 0. Or A minus B equals 0, right? So the idea is you can think of compare to as being minus. Right? Does that make sense? Everybody cool with that? All right. So what's your next question? You all really owe a debt to these people who sit in the front and ask questions. Don't know if you realize that. You should buy them something nice. Next question. No. Everybody understand? Yes, Bennett. Yes, regex. Regex are great, aren't they? Yeah. So let me just remind you. I made a regexer, right? So this is a place where you can go and practice your regexes. And I have a bunch of sample problems. So I can have like, just a basic pattern where I have the pattern is ABC, and then I have two different texts, and then I can do the match, and it shows me what matched. And so in this case, it finds the ABC in both cases, right? And that's not terribly exciting, but that's the very most basic example. And then I have, an example with groups, right? So I have A, B, C, where the B is in parentheses. So it's a group. When I do the match, it's going to find that group 1 contains the B, right? Do you have a specific way you want to narrow down this discussion, Bennett? Oh. Right. So I encourage you to access the website and go for the regex.php. You just play with lots of different patterns and see if you can understand what it's doing, and definitely make sure you understand all the examples. I mean, it's not terribly important that you understand the finding prime number one, but I kind of feel like that one's fun because it's so insane. If you remember that one. Okay. Yes, Olivia. Yeah. What is the output? Okay, so first of all, I definitely encourage you to just run these codes. So I have taken pains to make sure that they work. So it produces fab, but let's understand why it produces fab. Okay, so what this code is doing is it creates a class called key that implements comparable to, or class called myKey that implements comparable myKey. It's going to have its own char at method, which is going to extract a character from a string, provided that and it's going to do that correctly in case of boundaries, so you don't have to worry about that. But now let's look at the compare to method, which is the thing that comes from this interface. So I've structured this the way I always like to structure it, right? I put int diff equals 0 at the top, and then I have if diff equals 0 diff whatever. And so the point is, this will pick the first criteria that you want to sort by first, and only if that's 0 will the next one apply, and only if the first two are 0 will the third one apply. And then finally, you return the comparison result. So in this case, I'm starting with the comparison at position 1, which is the second character in the string. So I want to pick the string with the earliest value for the second character. In that case would be an A. Okay. The next character I want to look at is the end of the string. So I want the character with the earliest value. After assuming that the first two are equal, I want the last character to be the next most important one to sort by. And then finally, the first character. So if I go through this list, first I pick out the ones that have a middle character of A, right? So that's going to be fab and baff, right? So this first comparison limits me to these two. The next comparison, I'm comparing by the earliest last letter. And fab has an earlier last letter than baff. So fab is the winner. Does that make sense, Olivia? Good. What is the output? Okay, let's do this one. So it's going to say apple 3. So let's understand why it said that. Okay, so we have a main method. Inside the main method, we have a map that goes from string to string, or string to integer rather, and it's a tree map. So that means it's going to keep things in sorted order, correct? Yes? Okay. Some of you are nodding. Okay, then I'm going to say a try scanner SC equals new scanner, and then a string. So when I instantiate a scanner in this way, I'm parsing the string that I passed to it. So I'm parsing the string fish, fish, apple, bird, can, apple, apple, egg. All right. Now what I'm going to do is I'm going to say while sc.hasNext string word equal sc.next. So what this is going to do is it's going to iterate through all the words in the string. So it's going to, all those words I just read, it's going to take them in order. So first thing is going to say if the map does not contain exclamation mark there. If the map does not contain the word, I'm going to put word 1 there. If the map does contain the key, I'm going to put word for the value. I'm going to put map.get word +1. So I'm going to increment whatever's there by 1. So what's going to happen is in this map, I'm going to have, so fish occurs twice, right? So it's going to be fish goes to 2. Apple occurs 3 times, so it's going to go to 3. Bird is once, so it's going to go to once. Can is once, it's going to go to once. An egg is once, it's going to go to once. And now when I go to iterate through the entry set, which is going to get me my key and value, because this is a tree set, I'm going to get alphabetically the first key. And the first key is apple. And apple is in the string 3 times. So I'm going to get apple goes to 3. Is that good? All right. Next question. Yes, Panic.
Is tree the only map that keeps things like sorted order?
Yes, there's basically 2 maps that you have access to, hash map and tree map. You could write your own map, but you probably won't. And I don't know what kind of map it would be. Maybe you could make a hash map where each of the buckets is a tree map. Yes, Olivia. Yes, so the exception hierarchy, that isn't what I was hoping for. All right, there's what I was looking for. So at the top of this code, you see that the root of all exception classes is throwable, okay? There is a subclass of throwable called exception. And exception is a checked exception, and it covers all the things that potentially you would want to catch, right? Things that errors that you can handle: array index out of bounds exception, null pointer exception, file not found exception, all the things that you could reasonably be expected to handle with logic in your code fall under class exception. Alternatively, another class that descends from, that is another subclass of throwable, is error. And error are the class of things which should be fatal. Probably should be fatal. You probably can't recover from running out of memory, for example, no matter how hard you try. Yes, I have written code where I have tried, right? So I catch the out of memory error, and I call the system.gc and keep hoping, right? But generally speaking, error is something that you probably should not catch, and it is unchecked, right? So it's just going to kill your code if it happens. And then there is runtime exception, and that is if you want to have an error that people can handle, that you expect they can handle, but you don't want to force them to catch it. And actually, index out of bounds exception and null pointer exception are going to fall into this category, right? So that's the hierarchy. How's that? The various IO exceptions, though, all subclass exceptions, so they must be checked. Next question. Yes. The question mark thing. So the question mark thing is in wildcard.java. And the notion of the question mark is that it can be any class, right? So if I have question mark, then any list of any type of thing can go there, right? Whereas if I put list of object, then only list of object can go there. Question mark can also be used inside angle brackets in the following way. You can say question mark super T or question mark extends T, which means anything that extends class T or anything that is a superclass of class T, depending on which of those keywords you pick. And that's basically all there is to that. It's just, it can be anything. It stands for question mark, just stands for any possible class. And then you can qualify that with extends or super, if you so choose. And we have this notion of PEX, which stands for producer, extends, consumer, super. So you have this copy method here, where I copy something that extends T in my from array, in my from list, and I have T in the to list. So anything that extends T can be copied into a T, right? So that's the use of question mark. There's also a question mark operator, which we've never talked about in this class, because I don't like it. I think it looks cryptic and weird. Next question. This is your chance to understand stuff that you've never understood, that you've failed questions on. Vanek.
For the copy method, would it be a good idea to, in the type parameter for to list, would it be a good idea for question mark super T?
Well, you can, right? So I have in the examples here, I have any of these three will work. I can say list from, list T from list question mark super T to, or I can even do both. I can put question mark extends T and question mark super T. Any of those will work. The point is the compiler is going to say, okay, well, the one with the from array has an element that can go into the to array. And all of them sort of say that in different ways. Yet they say that same thing. We went over the last quiz. We did that at the start. Yeah. I know you all have questions. All you silent people in the back. Some of you might not. I can guess a few of you might not have questions, that you're just here because you just want to soak in the ambiance of the last day of class. I will, by the way, be at lab tonight. Tonight is when you turn in your final projects. If there's any, like, this is 10% of your grade, so it's a big deal. Make sure you have your 1,000 lines of code, that they pass through the checkers in the right way. And then you can take a victory lap, hopefully. But I will be there to answer questions in case anybody has anything that they need to work with me on. Yes. Okay, so let's go over the different types of sorts. We've discussed 4 different types of sorts in this class. We have bubble sort, right, where we compare things that are next to each other one at a time, you know, pairwise, and we keep going through the list until we stop making swaps. So that's a little vague. Let's try looking at the code. So in the bubble sorter, what we do, right, is we go through the array, we compare adjacent elements, and if they're out of order, we swap them. And we keep doing this until we could get through the array without finding things that are out of order. This is going to be an n squared. This is going to be an n squared sort. Then we have the selection sorter. And what the selection sorter is going to do is it's going to take the whole array and it's going to find the smallest element, and it's going to put that smallest element in the first slot. Okay. And then it's going to look at the subarray that starts after that element and goes to the end, and it's going to do the same thing. So it's going to keep finding the minimum of what's left and putting it in the next slot. And in that way, it's going to sort the entire array. This is also an order n squared array operation. Merge sorter is going to start by dividing the array into 2 equal-sized subarrays, right? And then those, and then when it, and then it's going to recurse into those two things. And he's going to keep recursing down into two equal size subarrays until those arrays are so small, right, that they're instantly sorted. Like if there's one or zero elements in the array, then it's already sorted. Okay, and when it has two sorted arrays, after it comes back from its recursive calls, it's going to take the two sorted arrays that it has, and it's going to merge them, right? You picture this like two decks of cards, right? You have two decks sitting next to each other. You find that you flip over the top two cards, whatever the smallest one is, you put it on this pile, and then you flip over that card that you put there. Maybe this one's the smallest now, you put that one there, and you keep going through and merge the arrays, constantly taking the smallest array, smallest element from whichever one has the smallest next element. And once you've done that, your array is sorted. That is an order n log n array or operation, right? Because of the iterative, because it iterates through and takes half the size each time, we have log n recursions that we're going to do. And on each step, we're going to do n, order n things. So we have n log n. Then we have quick sorter. And quick sorter is going to do, it's going to do things kind of in the opposite way of a merge sorter. First of all, instead of picking the midpoint, it's going to pick a random element. It's an algorithm that requires a random element. And then it's going to partition that array into three pieces: less than, equal, and greater than. And then it's going to recursively call quick sort on the piece, on the less than piece and the greater than piece. The equal to piece it doesn't need to do anything with. One of the, so generally speaking, in the timing tests we've done, the quick sorter uses less memory and is faster. The merge sorter, however, is stable. So the point is, if you've got two things that are equal according to your comparison operation, then a quick sorter might jumble them. So think of a spreadsheet, right? First you sort by first name, right? And then you sort by last name. But now two people with the last name might not be sorted in terms of first name anymore if you use a quick sort, where they will be if you use a merge sort. Okay, so there are different properties of these two searches. In the merge sort, we recurse first, and then we massage the data afterwards. In the quick sort, we massage the data first, and we recurse afterwards. How's that? Does that answer your question? Yes, Olivia. I will attempt to do so. This question? Okay. I see. All right. So it's going to just have a bunch of different outputs, and which of them are going to be true and which is going to be false. So let's look at our find group. Now, the find group is an example that I like for a recursive function because I think it's closer to something you might implement yourself in some real world scenario down the road. First thing I have to have is my exit condition. So what I'm going to do is I'm going to say if my position, well, okay, let's back up a minute. What find group does is it's looking to see in a group of values, right, if it can find some combination of those values that adds up to the sum. That's generally what we do with a find group method, but we're going to have a wrinkle in this case. So we're going to find out what the wrinkle is. Anyway, first thing that we do with find group is we create a helper method that has a position, an additional argument called the position. And I'm going to initialize that position with 0. So I'm going to start at the beginning of that array and I'm going to march through it. But I'm going to do it with recursion rather than iteration. Now, if pos is greater than or equal to values.length, that means I've gone through the whole array. At this point, if my sum that I'm getting of all the elements is not 0, then I have failed. If my sum is 0, then I have succeeded. And so if the pos is greater than or equal to values.length, I'm going to return true if sum is equal to 0 and false otherwise. Okay, now I'm going to create a Boolean called res, and I'm going to initialize it to false. And then I'm going to say, because I have to initialize it, and then I'm going to say int n equal 1. And what I'm going to do is I'm going to have this if statement. I'm saying if pos plus 1 is less than values.length, and values of pos plus values of pos plus 1, %2 is equal to 0, then n is equal to 2. So what does all that mean? It means that if there is another element in the array beyond the current one, and if the sum of the current element and the next element is even, then I'm going to set n equal to 2. So that means that I can't use the next element in the, well, and then this n is going to be how I advance through the array. So if I'm looking for something, so the next step in this find group process is first I check to see what if I use the value, what if I use the current value to try and make the sum and see if I can get to a successful result that way. And my next thing that I'm going to do is if that fails, I'm going to advance by 1 and try not using the current value. But if I use the current value, I'm going to advance by n. So that means that if the current value plus the next value adds up to an even number, then I'm going to skip it. So in this case, when I go to try to make a 5, if I use the 3, I can use the 2, right? Because the sum of 3 and 2 is odd. So the 2 is still available for use. On the other hand, if I want to make 6, I could do that with the 2 and the 4. But if I use the 2, then the sum of 2 and 4 is 6, which is even, which means I can't use the 4, right? So that's going to fail. That particular combination will fail. And then the next one I'm going to try is this 7. So the only way I could make a 7 is with a 3 and a 4. And since those aren't next to each other, I know it's going to work. So that's going to be a true. And then with D, I want to make a 12. So to make a 12, I need a 4 and an 8. But the 4 and the 8 are next to each other, and they add to an even number, so I can only use one of them. So that's going to fail. Finally, the last one, I'm going to try to make a 13. I could do, how could I make a 13? I could say a 3, a 2, and an 8, right? That would make 13. And if I use a 3 and if I use a 3, I can also use the 2 because the sum of 3 and 2 is odd. So that means I can use them both. And then I can also use the 8. So that's going to be true. Got all that? All right. Yes. I could use all the numbers if I want to. It's going to check. It's going to go through this and it's going to check. Can I use the current number? If I can't use the current number, I can use the next number. There's no limit on the number of numbers it can use. If I have an array of 1,000 things, it can use 1,000. It can add all 1,000 of them up. Panic.
So only if you use the value, it changes the n to 2.
Well, yes, only if I use the value. So that's saying I can't use two values that are next to each other if their sum is even. Right? So your whole job, you should have understood the code without this line before the exam. And your whole job on the exam is to understand what that line did. Okay? Next question. You got a question? You thinking one? No? Yes. Yeah, we could look at the first question again. So 2 days ago, yeah, not yesterday. Right, so in this case, what we did, right, is we needed a generic class. The node class does not call compare to, so it doesn't need the extends comparable t. So I can put an angle bracket here, angle bracket t here to say that it takes a generic type t. When I declare the left and right subnodes, I need an angle bracket t as part of the type name. But a constructor is special. I don't put the angle bracket t there, so I put the nothing there. Now on the binary tree class itself, I'm going to call the compare to method. So I need t extends comparable t in this slot. And in this slot, I need the angle bracket t as part of the type name. Actually, I'm allowed to use angle brackets and empty angle brackets there and let the compiler fill it in, but I didn't give you that option. I was trying to give you one option that was correct. Yes. Well, we went over this with Olivia just a moment ago, right? So a compare. So if we have, we have two strings here. Strings are comparable to each other, right? But this other class, comparator C, is able to compare two things, right? It itself is not going to be the subject of the comparison, but it's doing the comparing. Just like, you know, professors are comparable. You can compare how great we are, and yes, I'm the greatest. But so we're all comparable, but you're the ones comparing us, so you're the comparator. And you're saying, yes, you know, Professor Brandt's class, I get my grades right away. I always know where I stand, you know, and there's, you know, there's never any ambiguity about what's right and what's wrong on a quiz or a test. And, you know, I always know what we're going to be doing in the next class. It's so organized. Isn't it great? He does code live in class. Wow. It's like jumping through a ring of fire. All right. Any final question? I think we're down to the last minute or two. Are you all ready to go and make me proud and get 100% on the exam, on the final exam? I'll take 95, but 95 is acceptable. All right. I'll see you at bright and early at 7:30 a.m. for the exam.